Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. We got a river flowing into a lake, and we have a turbine at the bottom of the river before it reaches the lake. We want to find the total power generated, and we have the volume flow rate, which is 501 cubic meters per second. The height of the river to the lake is 91 meters above the lake surface, and we have the velocity of the river, which is 4 meters per second. Step 1. Draw your free body diagram, your FBD. This will help you visualize the problem. So blue is the water. We have this river, and we have the lake down here. And this blue dot is the turbine. And we have the height at 91 meters. The current of the river, or the velocity, is 4 meters per second. Okay, step 2, list all the given values and the unknown. So they give us the velocity, which is 4 meters per second, the height is 91 meters, and the volume flow rate is 501 meters cubed per second. Do not confuse V dot with V. V is velocity, V dot is volume flow rate. The unknown is power. Power in this case is work flow rate. So W is work and the flow rate is the dot. Step 3. Find the formula for power. So we want to find the maximum power. So that is W dot max is equal to E dot mechanical, which is mass flow rate multiplied by the specific mechanical energy. Alright, step 4. Find the specific mechanical energy. So little e mechanical is equal to the specific potential and the specific kinetic energy combined. So that is gravity multiplied by height for your potential energy specific, and your specific kinetic energy is your velocity squared divided by 2. So we're going to break it down. We're going to find kinetic energy first because they give us that, and then we'll find potential energy. They also give us the height, and then we'll combine it, and then we'll go backtrack and find the mass flow rate. Once we have all the components, we will find the power. Okay, so step 5, find the specific kinetic energy. So we just plug and play. So 4 meters squared divided by 2, then multiply by your conversion factor to get kilojoules per kilogram. So that is 0.008 kilojoules per kilogram for your specific kinetic energy. Step 5. You want to find your specific potential energy. So that is gravity multiplied by height. So 9.81 meters per second squared multiplied by 91 meters multiplied by your conversion factor. You'll get 0.89271 kilojoules per kilogram. Step 6, you combine them. So you combine the specific potential with the specific kinetic, and you will get 0.9007 kilojoules per kilogram. Step 7, find the mass flow rate formula. So m dot is mass flow rate. So m being mass, and the dot above is the flow rate. So that is density multiplied by volume flow rate. So for density, it is the density of water. So step 8, find the mass flow rate. The density of water can be assumed from the clue given in the question. So it is both a river and a lake, or a river going to the lake. Both of them are fresh water. They're not salt water. So we can assume that it's 1,000 kilograms per meter cubed. You can look this up in your charts or your textbook. I can't show you the textbook, but if you read the pinned comment, you will know what page it is, depending on what textbook you have. Okay, so 1,000 kilograms per meter cubed multiplied by 501 meters cubed per second. You'll get 501,000 kilograms per second for your mass flow rate. Now we can finally backtrack and find the power generated. So it's mass flow rate multiplied by the specific mechanical energy. So 501,000 kilograms multiplied by 0.90071 kilojoules per kilogram. So the units will cancel for the kilograms. You'll get kilojoules per second, which is a 1:1 ratio for kilowatts. So you will get 451,255.71 kilowatts. So if we convert that to megawatts, it's 451.255 megawatts. So 451.255 megawatts is the power generated from the river being discharged into the lake, where the power is completely recovered from the potential energy as well as the kinetic. Okay, just a note that the kinetic energy is very small and it is negligible in the calculation. As you can see right here, it's very small compared to the potential energy. Okay, we also know that the actual turbine will have less than 451.255 megawatts because of losses and inefficiencies. So this will be losses from flow energy, friction, and also just power conversion as well. Okay, before we leave, disclaimers. The method is correct, however, I do make calculation mistakes. So I encourage you to solve it yourself and see if you get the same answer. I also highly encourage you to save this video onto your PC, just in case this video or channel gets taken down. While I follow all copyright laws, sometimes things just happen. You can do this by using snipping tool. If you're on a Mac, you can use the Mac equivalent. If you have never used snipping tool before, follow these instructions. So go to your taskbar, click on the icon. If it's not in your taskbar, go to your Windows search, type in snipping tool, open the program. Once it's open, click on video option, click on new. Left click and drag the rectangle to cover the YouTube screen. This is just an example. Then hit the start button in snipping tool, wait for the countdown, hit the replay button on YouTube, let the video finish, hit the red square in snipping tool to stop recording, and then save your video. So, thanks for watching. Hope you had a great day. Be sure to like and subscribe, share with your friends, because this is a made-up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistake in this video, leave it in the comment section. I will get back to you as soon as possible. If you want to support me, become a member or drop a super thanks. Until next time, see ya.